And I'm going to silence my microphone for just a second so you don't hear me on YouTube and in here. Okay, good evening, everybody, and welcome. We're so glad to have you all here with us. Welcome to Live from LPSC. We're delighted to have everybody. And Grace, you have some slides, some introductory slides to show. And hello, Dennis from Wisconsin Solar System Ambassador. Everyone who's here, you are welcome to enter things into the chat or into the polls. Gary, Texas Solar System Ambassador, we're glad to have you all here. Welcome, welcome. We are speaking from across the United States. Several of us are in Houston, Texas at the Lunar and Planetary Science Conference, which is going on this week, finishing up tomorrow morning. So today just finished up the 4th day of talks and poster sessions. And we are going to be having a great time. While people continue to join us, we're going to go ahead and launch our very first poll to find out a little bit more about everyone who is here with us. So in this poll, you have a couple choices. We want to find out more about those of you who are online with us right now. The first question is, what brings you to tonight's event? And you can answer multiple things. You don't have to pick just one, you can pick multiple things. And then the second one is, have you ever attended any of the Lunar and Planetary Institute events, virtually or in person, before? Because we've been having both. So, and while people are answering that, let's go ahead and see who's with us. Ola from Florida, hello from Michigan, hello from Florida. We're so glad to have all of you here. You know what, Grace, I'm going to make you the host. If you can make me a co-host after I'm done with that, I think that'll work.
Okay.
And Freeport, Texas, Alan, past employee of Johnson Space Center, Prairie View, Texas, Utah, Illinois. We've got this esteemed specialist from Buffalo, New York. So people from all over the place. We are delighted to have all of you with us here. Louisville, Kentucky, Katy, Texas, Andrews, Texas. So we're going to give folks just a little, oops. And Grace, since I made you the host, I can't close the poll anymore, so I'm going to let you. We're going to give everybody 10 more seconds to finish answering the polls. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And let's see where everybody's from. Awesome. So, so people are here for a variety of reasons tonight. Enjoying to learn about the solar system is a key reason. Amateur astronomer, curious about planetary science. Some of you are planetary scientists yourselves. And then about 2/3 of you have attended one of our events before, and about 1/3 of you haven't. And nobody's unsure. So that's interesting. Cool. Everybody knows yes or no. We're so glad to have all of you with us here tonight. So tonight, this evening, there are, we have some great folks here, some great scientists here at the Lunar and Planetary Science Conference, and we range in terms of our experiences and what we're studying. So folks, you can see Eva Scheller, Caitlin Ahrens, Sharissa Thompson, and Paul Byrne, all here with us. And they study a variety of different things in the solar system, and they're at different levels in terms of their experiences. And we're so happy to have all of them here with us tonight. So the first question for all of them, we're going to go around, is we're going to find out just a little bit about what was really exciting this year, something that you heard this year that just really excited you here at the conference. Anyone want to go first?
I'll go first. So hi, everybody. So I think a really exciting part about LPSC that I found absolutely fascinating was so many missions. We're going to be so busy in the next decade. And so we planetary scientists have something what's called the Decadal Survey. That is going to be coming out for us very, very soon. And because of that, that gives us almost like a giant roadmap of how do we, as planetary scientists, prepare ourselves for developing new instruments, developing new teams and missions and science objectives. But all of that decadal survey isn't just one person sitting in the corner going, this is what we're going to do. It is the entire planetary community coming together, writing white papers, and then marvelous, fabulous teams, and Paul can definitely explain more about decadal survey fun. But that's the exciting part, is we're going to have that soon. We're going to have so many exciting missions coming up in even by just next year. We're planning to go back to the moon. We have a lot of fascinating Venus missions at the ready. We got Europa Clipper. We got Dragonfly. So planetary science is going to be very busy, and that's what's going to be very exciting for all of us to kind of get our wheels turning and excited.
Thank you so much, Caitlin. Awesome. Awesome. Eva, would you like to go next?
Sure, I totally concur with Caitlin in terms of all the many exciting missions coming up. I think maybe I'm a little bit biased because I'm a member of the Perseverance rover team, but of course I was really excited to see all of the great results being presented here, because the way that it works on a rover team is that you're actually a big science team of maybe 300 scientists analyzing the data every day, going in and discussing it. And it takes a really long time actually to put all those results into a story that we can share with others. And so it was actually here in the past couple of months that those stories really came to be, and a lot of them were presented here at LPSC this week. So that was really exciting for me. But I'm also very excited about the other missions going, not only for Mars sample return, where we're actually, collecting these rocks to maybe be returned, hopefully be returned back to Earth. But I was also following along a lot of the Venus missions that are coming out of both NASA and ESA, and the preparation that's going on for studying Venus again.
Thank you so much, Eva. Charissa, how about you? What did you particularly find interesting and exciting this week?
For me, this week was just hearing the different talks of varying ideas that sometimes combated each other, but also sometimes would coexist with each other. And all day today, I sat through Mars talks, and there was just one after another of, yes, this connects to my recent talk on this. And as you can see, this further proves this idea or this theory that we have. And I loved seeing that, but I also love seeing the side of it where it's just well, I actually think there's this other theory and that this could be proven from this. And it's just refreshing to see both sides of the science of the ideas going around the room and the discussions we had during the sessions. And it was amazing to be absorbed in all of the science and the minds of scientists all together.
Thank you so much. And Paul, how about you? What was most exciting for you here?
It's kind of hard for me to pick just one thing, but I'm going to be super partisan and say it's the fact that we had a whole day of Venus talks. And from what I understand, it's probably been more than 25 years since LPSC has seen that, because there just hasn't been any new data really, at least not for the surface. And even though we still don't have new data for the surface, we're going to get some. Eva mentioned this and Caitlin mentioned this, that we found last summer that NASA is going to send 2 missions to Venus by the end of this decade, and ESA will send one the next decade. And we're going to see people turn to Venus who may have worked on it in the past, or people who perhaps have never thought about Venus, starting to kind of turn their attention and bring their expertise to it. And I think that's going to be extremely exciting. It's not just that we're going to get new data, we're going to get more people and more new ideas to explain what we see on Venus. That's incredibly exciting for me.
Thank you so much, Paul. Now, while we're still focused on you, let's go ahead and have you share just a little bit about yourself, about what you do, and about, sort of your interest in Venus, right?
Sure, yeah. So I am a self-confessed Venus evangelical. And, I got interested in Venus about 6 years ago. Previously, I had studied Mars and Mercury. I did a lot of work on Mercury and the Moon, really anything in the solar system that has a solid surface. But about 6 years ago, I began to really study Venus. And at that point, I was joining a group that had been up to that point relatively small and had been asking for decades for more data, because we have these really interesting things that we can't quite explain for Venus. But in the last couple of years, there's been a couple of big changes. One of them is that we've had new climate models for Venus that suggest that its history may be more complicated than we think, and it may have been more habitable for longer than we once thought. And the second thing is, in the last 10 years in particular, we've been finding more and more Earth-sized exoplanets, planets that orbit other stars. And we do not yet have an ability to be able to distinguish whether or not one we find that's Earth size is a Venus or an Earth. And so there's a renewed emphasis, I think, in going back to Venus to try and answer questions as to how it ended up the way it did, that we don't really understand right now. But it's not just for understanding Venus, it's also to understand why Earth ended up the way it did, and even why, or what we might expect to see. Is Venus common, or is Earth common, orbiting other stars? So in the last few years, it's gotten particularly interesting. And Caitlin alluded to this a moment ago. I've just come off being the chair of the Venus panel for the National Academy's Decadal Survey on Planetary Science and Astrobiology. The Decadal Survey will be released, we hope, in the next few weeks to the community. And like Caitlin mentioned, it's going to be a roadmap, a set of recommendations for NASA and for the National Science Foundation over the next 10 years, which will encompass everything from IDEA, funding levels, how we can grow our community and allow it to thrive and make sure that everyone's voice is heard, but also what kinds of missions and technologies we have to develop to address the cutting edge critical science questions that we've identified. Venus is definitely going to feature in the Decadal in a big way, and I cannot wait for it to come out.
Awesome. Thank you so much. Sharissa, you come at this from an original viewpoint from the rest of us. Can you share a little bit about yourself and what you're doing, and which fields in terms of planetary are of interest to you, because so much is going on?
Yeah, so I am a first-year graduate student at the Institute of Georgia, or Georgia Institute of Technology. And I originally got into planetary work last summer in June, working with Dr. Marty Gilmore for the super internship. And that was my big entry into the planetary world. And I was just super into the work I did with her over the summer. And then I got into graduate school, and now I'm working with Dr. Francis Rivera Hernandez. And I'm working mostly on Mars using terrestrial analogs to look at mud volcanoes or mud volcanism, where it's just sediments that are erupted from the subsurface or beneath the surface. And I just got really into that because her postdoctor, Jacob Adler, was working on the research. And we actually have collaborators in the UK who has a SMARS chamber where they have conducted study or analog experiments to try to resemble this flow of these sediments going down a slope. And I was just I wanted to get hands-on with the work, and it intrigued me so much that I just decided to work with mud volcanoes on that.
Awesome. Thank you so much. Was there anything this week on mud volcanoes in particular that really interested you?
Yeah, there is actually at least one talk that I got to hear by Mackenzie Mills, and it was trying to focus on the amount of sediment that is extruded from these cones, these pitted cones on Mars. And it was trying to recreate this through her study and find parameters that will show how much sediment is needed to create these features that we do see on Mars. And I thought that was really interesting because it kind of correlates with my work of recreating them just in a different context.
Thank you so much. So speaking of Mars, while we're still on Mars, Eva, would you mind please, Dr. Eva Scheller, please share a little bit about yourself and your research and some of the other things about Mars here that were here this week that that really you thought were interesting and new and innovative about Perseverance.
Sure. Yeah, so I'm actually, well, now I'm not a PhD student anymore. I actually defended 2 weeks ago, but I'm still at Caltech, which is where I did my PhD. And in the past, like 4 years, I've been a member of the science team of the Perseverance rover. I've also worked on a bunch of the other Mars missions. I've been on the Curiosity rover and the Mars Reconnaissance Orbiter as well. And I study a lot of different things about Mars, I think mostly pertaining to understanding the history of water on Mars and what it means for the Martian surface potentially having been habitable. So that means whether the surface would have had environments that could have sustained organisms or not. That's something that I study in a lot of different ways. And one of the ways that I've been studying it is with a particular instrument on the rover that's called the Sherlock instrument that I and others on my team actually use to find organic compounds on the in the Jezero crater, which is the landing site of the Perseverance rover mission. And I think it, you know, as said, one of the most exciting things coming out of this Perseverance study is that we now have a full understanding of this landing site that we landed in, which is sort of the floor of a big crater. So a crater is created when you have a giant meteorite punching a hole into the ground of Mars. And there seems to be this very complicated sort of volcanic environment, but this volcanic environment has also interacted with liquid water, and that story is really coming to life now. But aside from Perseverance, I was actually also very excited to hear about some of the results from the Zhurong mission, the Chinese first rover mission as well.
Thank you so much. And Caitlin, your turn. You've got a very complicated background and a very complicated field of study as well. Please share with us.
I think earlier I described myself as a mixed bag of nuts here. So Paul knows me. So I mainly deal with ice everywhere. If it's ice, I'm going to play with it. So I had done experimental work for my PhD. I used to collaborate with a lot of New Horizons folks with Pluto. But before that, I did Mars mineralogy mapping using Mars Global Surveyor. Now I specifically am part of the Diviner Science team with the Lunar Reconnaissance Orbiter. And my job is to figure out where are all the cold spots on the moon. And fun fact, it's not just water ice. So my job then is to figure out where's cold versus colder, and then what kind of volatile ices are we dealing with? How could we potentially go study some of that with landers and rovers and then eventually crewed missions? How do we study those ices safely? Preserving those ices is what I'll be actually working on this summer. But besides the moon, I also work on a lot of cryovolcanism. So think volcanic systems, but with ice. So water ice, cryo lava, but everything is just super cooled down. So we're dealing with methane and nitrogen and ammonia, just all slushing around on different icy bodies throughout the whole outer solar system. And they can all come in different shapes and sizes. They can all have different levels of activity, like geysers, or just little bits and pieces of puddling. So I'm just kind of skipping around all over the solar system when it comes to ice.
Thank you so much, Caitlin. And so while we have Caitlin, and actually for everybody, I wanted to invite you to share well, actually, let's answer Bob's question before we move ahead. Bob wanted to know more about whether any aquifers might still exist on Mars from the wet times. And a cute joke here from Helen about Ice Baby. So, Caitlin, or anybody here, Eva, do you think, is there any evidence that aquifers might still be able to exist on Mars right now from the wet times? Or is it still out for more information?
Sure, yeah. So I can maybe start, and feel free to jump in if anyone else has an opinion on this. Well, it's interesting, and it's actually one of the things that are in the flow of thoughts for new mission concepts, because the short answer is we haven't really actually had a mission that can go and look for liquid water aquifers. It's a little bit hard to look in the underground of a planet. Like most of the missions we have addresses the surface materials mostly. And so that's one of the ideas for new missions, is actually going to search for these aquifers. But let's say we haven't seen them yet. What we have seen, though, is a lot of underground ice deposits. So we know actually in certain cases where the underground is exposed, you can actually see ice underneath the ground in there. No liquid water yet from the underground directly observed, though.
And anyone have anything else to add to that?
I'll add just to what Eva said. That's absolutely right. Planetary exploration is extremely difficult. And it's possible that there may be liquid water at depth on Mars underneath a layer of frozen ice, which is probably not a pure layer of frozen ice. It's probably inside the pore spaces of rocks. But it could be quite deep. And it's going to be extremely hard for us to develop a robotic spacecraft that could get down that deep. Even the ExoMars Rosalind Franklin rover, the fate of which right now is uncertain, it's planned that it would drill down about 15 meters. But we may need to go much deeper. And that may require crewed missions, which will be a few decades away, where humans are actually setting up research stations on Mars to go and actually look for that material. There's very good evidence that Mars has had a long history of water, the extent of which is still actively debated. One of the debates we saw at the conference this week was, did Mars ever have a northern ocean? That case is still by no means certain. But where that water is today and how we might get to it it's not easy to get to, which is the case for most places. It's not easy, and we may have to have humans there to get there.
Absolutely. Thank you. Thank you. So, Sharissa, I've got a question for you, and then everybody else on the team. I'd like everyone here to share a little bit. Why is coming to a conference important? What do you get out of it? What does the science community get out of it? Why is it important? Because each of you was able to be here in person for at least part of it. This was a hybrid conference, so people were on virtually and in person. Why is it important to be at a conference? What's the role of a conference? Sharissa, would you mind sharing your thoughts first?
Yeah, I definitely feel that for people at different stages of their career, there's different purposes of the conference for them. And for me as a graduate student, especially in my first year, this is just a way to introduce myself to the community and meet other members of this community, and just be able to hear their science and share my science as well. For this conference, I have a poster that I'll be presenting today, actually. And so it's my chance to interact with people who have similar interests or have done research and get their take on it and their understanding of it, and get also help with my research from other scientists at this conference. And they can give me advice as well as things that I may have done wrong. And I feel like that's really helpful at this stage in my career, because then I can work on it for future conferences and future papers that I may write. So I feel like that is the big plus for me for being at this conference, and just networking too. Yeah.
Thank you so much. Well, let's move ahead to Caitlin. How about you? Same question. Why a conference is important?
I'm going to echo Sharissa here. Is just the again, back to the excitement of just everybody doing wonderful and amazing things. But the interesting part about planetary science too is that we're very interdisciplinary. And so you have to have the constant collaboration and sharing of ideas. If we don't know a particular type of ice, can someone run experiments? Can someone go and find it on Earth? Or can someone map it on a different planet? Can we then develop an instrument to then study that ice on a different planet? So we have to talk to engineers. Is there an astrobiological implication to our science? So we have to talk to biologists, we have to talk to astronomers. We also have to talk to heliophysicists sometimes. If our work gets affected by solar radiation, we have to talk to chemists. So we all come from different backgrounds. And from that, we all develop different ideas and different points of view, all on even just a tiny bit of, say, Mars, for example. You can have so many different backgrounds and have not one conclusion all be the same. But that's the fun part then. Then we all try to piece together, well, what did he mean by this? Oh, I didn't think about this. And it's the constant sharing of ideas. And so having that in person, after not seeing each other for a while, really gets everybody excited, maybe a little bit exhausted too, but it's the constant sharing of ideas.
Thank you. Eva, how about you? Do you have anything to add to that, or do you want to echo any of those statements in terms of why do we have conferences?
Sure. Yeah, I can totally echo Caitlin and Charissa, and sort of the little notes had many of the same points that were already said. I can maybe add from the perspective of being on these mission teams. Like if you're in a very active mission team, you can totally get sucked into your little instrument data set, and the conferences when we go and we meet everyone else from all these other missions that are actually addressing the same questions from different instrument, different perspectives. That's when really new creative science is created. And that's, I think, maybe my most favorite process of science as a whole. So that's a really important aspect. And then it's also just nice to meet your friends once in a while, friends that you don't get to see very often. So it's also, just saying hello to people that you haven't seen in a while.
Awesome. Thank you. Paul, not least, but last on the same question, please.
I echo everything that everyone has said already. It's just being able to go and share your ideas. There's something intangible about physically being with people that's so hard to replicate. Although it's important that people who may not be able to travel for a variety of reasons are able to participate. Actually physically being in person and seeing people and sharing ideas with them and getting feedback and rekindling research relationships is extremely important. And there is no substitute to be able to actually meet people and be at these conferences. And, I've been going to LPSC for a while now, but it is where I've met most of my colleagues and friends in the planetary community and gotten really good feedback and come up with new ideas. You cannot really get that anywhere else.
Awesome. Yeah, I see several comments in the chat. Bill mentioned that this is a way for the public to hear from and talk to the planetary scientists as well, because of the reporters here and other members that are here at the conference getting to hear from. And then Helen echoed this idea of the cross-pollination of ideas, and Grace added that building a community is key for this as well. So we've received several questions so far. Let's go ahead. Who would like to cold samples? We've got a question about cold samples. And the question is, how could we preserve cold samples while we run tests on them? Wouldn't that require really unusual lab settings or special instruments? And how cold are we talking? Who would like to answer that?
So, cold stuff. Yes. That is something that we're still trying to figure out, because it does depend upon what kind of ice sample you're wanting to get. If it's just a nice tiny little ice cube off of Mars, you're not going to really, you're going to have to be careful with contamination, obviously. but it's not going to be as risk heavy as getting ammonia ice, let's say, or even sulfur type ices from the moon. And so having those type of technologies is what I myself and a lot of my colleagues are working on at NASA Goddard actually right now. So so stay tuned, because we're still working on it, and we need to prep ourselves for the eventual Artemis crewed missions coming up, so in a couple of years. And so we're working on it, yeah. But when I mean cold storage, a lot of these ices need to be, I work in Kelvin temperatures, because Fahrenheit, it doesn't cut it for us. So a lot of these ices on the moon can get just as cold as Pluto. Very cold. So -400 some degrees Fahrenheit is what we're dealing with. Duh, pretty cold. But yeah, so trying to deal with how do we preserve the ice, and obviously don't let it evaporate and melt by the time you want to study it. So that's the challenge.
Thank you, Caitlin. Eva, we've got a YouTube question for you from Daniel. The failure of the mole on Insight that, had problems was heartbreaking. Could Perseverance see a temperature gradient if it digs deeper? What do you think?
Sure. We have tools to dig in the rocks, but unfortunately, we don't have any thermometer to take the temperature of the actual rocks. I believe we have thermometers to measure the temperature of the air, so the atmosphere, to record the temperature there. So unfortunately, we can't take the temperature of the rocks, but there is sort of there's a chemistry problem that can actually allow you to understand the temperature that the rocks were formed at if you go and analyze the chemistry of the rocks. So that's something that we are doing. So you can sort of calculate what the old temperature that would have formed these kinds of volcanic rocks that we're seeing would have been. So that's one way that we could get at the temperature question.
Thank you. Now, this next question is going to be a toss-up for everybody. So advice, so if some of our attendees here work with kids, work with children, and they want to give advice for those kids on how to get into planetary science. So what advice would you have for children on getting into planetary science? Anyone want to go? Sharissa, we haven't heard much from you in the past second or two. Let's start with you. What do you think? If a little kid, brother or sister, somebody wanted to know more about advice in terms of getting into planetary science, what would you tell them?
Well, for a brother, I would tell him that there's a lot of opportunities to do work in programs over the summer through NASA and other planetary societies or departments that allow you to work with other people at your level and get into the nitty-gritty of it all. And you can either do hands-on experimental work with it, or you can do more computer and analytical work. And I'm not sure about little ones. I guess for my advice for younger audiences or children, it would be to just go to any place that may have these like the museums that have the programs within them for kids. And I also do know for some local museums, coming from Boston, we have the Museum of Science, and they have some programs there too as well. So I would just say, get on Google and just look up programs in your area, or try to see if the museum hosts anything either during the summer or an after school program, because there are a lot of work that they do with the public, and they want the public to come to their area more and just get into the science a lot more. So there's always those.
Great points. And Caitlin, you had some things to add to that.
Yeah, and then Bill, thank you, Bill, for for starting that conversation. I was going to say just what Bill just put in the chat. Yes, local astronomy clubs are the best thing ever. So be sure to definitely Google. They are everywhere. A good place to start is called the Astronomical League. They keep track of all the local astronomy clubs per state. And the interesting part about astronomy clubs is that you don't need it to be an expert, like, at all. If you like space, you're in, you're good. But what was nice about, I grew up in a rural West Virginia community, and so I didn't have very many resources growing up. There weren't that many science museums nearby, unfortunately, that I could travel to. But I joined a local astronomy club and got to interact with scientists at a younger age, and got to interact with how did telescopes work. And we went on field trips together in my astronomy club. And it just kind of snowballed into, what else can I do? Who else can I meet? Astronomy clubs have a very wide, broad network that they're like, oh, if you want to meet so-and-so, we're going to talk to this club in New York. We're going to talk to this astronomy club in South Carolina. And it's just a very broad network for a range of ages. And astronomy clubs also are very fun to work with, where, say, like, you just got a telescope and you want to learn how it works, you go to them. But it's not just for that. I feel like astronomy clubs kind of get that kind of reputation of, but I don't work with telescopes. That's fine. It's for space enthusiasts, and it's fantastic to start for smaller ages and let them build up the passion organically.
Well, something sort of related to this in terms of who is scientist and who's able to be a scientist. In your opinion, I'm just going to ask for like thumbs up or thumbs down here for this. Do you know, are all scientists geniuses? Do you have to be a genius to be a scientist? Thumbs up, yes, or thumbs down, no? No, you don't have to be a genius. Do you have to work hard to be a scientist? And keep trying, even when you make mistakes? Do you have to make straight A's to be a scientist? No. So in terms of the kids need to know that they can be scientists too. They can, it requires work. It doesn't mean that you're going to get all the answers right all the time. You have to keep trying, but you have to really love doing it, right? Do each of you love what you do? You probably wouldn't be scientists if you didn't. So awesome, awesome. We have a number of other questions coming in. There's one here that's interesting. What's the chance of an asteroid hitting a base? And I think that they mean moon-based, but they could also mean Mars-based or something like that, a base on another planet. This has many multiple answers. Paul, I'm going to throw this one to you. I haven't heard your voice in a few minutes here. What do you think?
Sure. So the answer is it depends. The chances of being hit by small things are pretty high. In fact, they're about 100% on the moon, where there is no atmosphere and therefore no shield of any kind to stop small things hitting the ground. But those small things might not be a problem, because we would know that. In fact, we do know. We've had a spacecraft orbiting the moon. Caitlin mentioned it earlier. She's working on the Definer team. We know that we've been imaging the surface for 13 years now. We know how frequently stuff hits the moon, which is pretty cool. We also, by the way, and this is segueing back to the whole astronomy club thing, there are thousands of people who are amateur astronomers who point telescopes at the moon to look for what we call impact flashes, which are the little bright bursts of light when something slams into the moon several kilometers per second. So we know the rate-ish of which stuff hits the moon. We can build to that. We can build bases. Astronauts may end up working underground in berms that we use lunar soil to build up, or even lava tube tunnels where lava once flowed through that have now frozen and now are empty, would make great natural refuges for astronauts on the moon. So they'd be okay from the small ones. On Mars, there is a little bit of an atmosphere. It's not much, but there's a little bit of one, and it will protect the surface from the very smallest impactors. it is a risk, but it's not a very big risk. There are much bigger risks to humans doing stuff out in space, like things like radiation, or even the effects on the human body of low gravity for extended periods of time. In fact, one thing that we have a really hard time simulating is what happens psychologically to people when you put them in a spacecraft and fire them off to Mars for 9 months. We've never, ever done that before, and we don't quite know what would happen. So yes, the stuff hitting the ground is a risk, but it's pretty low down, the things that probably keep astronauts awake at night.
Thank you. And while you're still speaking, Paul, there was a question here about Venus. Why are scientists interested in Venus? What does it tell us about the Earth? And what will these new missions accomplish that we don't already know? Why should we care?
Why should we care? Okay, well, so here's the basic answer, right? As interesting as Mars is and the moon and all these other worlds, there is only one Earth-sized object in the solar system aside from Earth. And it is anything like Earth. The surface is the temperature of a self-cleaning oven. The pressure is the equivalent of a half-mile underwater. It is just vastly different. How is it you can start off with two worlds the same size, made of about the same stuff and about the same ratios around the same star that are about the same age, and have two completely different outcomes? That's the question. And some of our models suggest that Venus may actually have been Earth-like for a long time, and then something catastrophic befell it. Other models suggest that it always started off terrible and hellish. But the fact is we don't know. So to the question of, what will it tell us that we don't already know? What we do know about Venus fits on a postcard, and it just happens that there's two things that govern this, right? There's the science that drives us to go to certain places, and there's the technological challenges that come with exploring those places. And it has been easier to explore Mars because you can see the surface from space, you can land, you can rove. The longest anything human made has ever lasted on the surface of Venus was 127 minutes in the 70s. Because it was so hot, the electronics fried. Venus is hard. That doesn't mean it's not important. And there's now a growing inertia in the community, both in the US and internationally, to start pushing for a renewed era of Venus exploration. And I, for one, hope that the missions we're going to see are just the first wave in a series of missions to explore Venus that will someday end with us roving on the surface of Venus. We will be able to build the technology to do that. It's maybe 50 years away, but we'll do it. And once we have that and we have those spacecraft and those capabilities, we'll be able to fundamentally answer this really important question. If you start off with an Earth-sized world, is the outcome planet hell, or is the outcome squirrels and trees? We don't know the answer to that question. And if we're going to make sense of our own world, we have got to study Venus. So that's why Venus is so important.
I also have a fun addition to Paul's comment on that Venus and Earth are around the same size. And in the learning phase still, I recently had a homework question on solving what would the atmosphere thickness be and the mass of it if the world's ocean was in the atmosphere instead of evaporated into the atmosphere. And it was actually thicker than Venus's atmosphere. So that was just something really interesting that I'm just like, wow, that's crazy that we could, if we were maybe a hotter planet, have an atmosphere thicker than Venus if it had all evaporated for the ocean.
Yeah, and you know what? We know
Awesome,
the sun.
Teresa.
The sun is going to get. I'll just say
Some
one last
Mars
thing.
questions too. Let's see. Here's one that was posted by Isha. Eva, I was wondering if this one might be a good one for you. They want to know about the peroxide in Mars soil and the lack of nitrogen in Mars. Do you want to add anything to that?
Sure. I can give my take on it from the way that I understand the question. So it's true. I think peroxides were found all the way back in our first Mars probes. They found peroxides. And it was sort of like if you have a lot of what's called like highly oxidizing conditions. So that is you have so much oxygen that you can actually start destroying, for example, organic compounds. That's a concern when you have compounds like that. I can't say that from the Perseverance findings so far, we haven't seen any peroxides. We have seen other kinds of, again, these highly oxidized materials that we have to be really careful with in handling the samples when they come back for when we're going to do our analysis for the organic matter. So that's one thing to think about. So in terms of the lack of nitrogen, so I'm going to assume this is about the atmosphere because, of course, on Earth, nitrogen is a huge part of Earth's atmosphere, and Mars's atmosphere is primarily CO2, and it's much smaller. It's really, really thin. And that's a really big difference between Mars and Earth, and there are implications for whether organisms could be sustained on Mars or not. We still think that there are many places that organisms could have existed. One of them, so one of the things that a really thick nitrogen atmosphere does is it actually protects the surface from radiation, again, that can destroy organic matter and microorganisms. So one idea out there is that life could actually have maybe lived underground, and that would have been a different way to protect themselves from the radiation, even though there's such a small atmosphere on Mars. So that's my take on those two. I hope that helped.
Thank you. I appreciate it. Caitlin, I'm going to let you add to that, but before you do, there's another question from Dennis about Mars orbiters. Do any of them have any ground penetrating radar looking for underground water? Do you know the answer to that one?
I'll answer this one.
Okay, so Eva, we're going to toss that one to you. Do you know anything about whether any of the orbiting missions happen to have ground penetrating radar to look for underground water?
Yeah, so we actually do have, on the Mars Reconnaissance Orbiter, we have a ground penetrating radar. It mostly looks for ice. So it's really good at looking at, for example, like ice layers in the poles. Sometimes you can use it to look for different kinds of rocks in the underground as well, but it is not enough to actually look for underground water. There is a new mission, actually, the Mars Ice Mapper mission, that is going to be another radar looking for more ice. So I think the idea still is that if you want to look for underground water, you're probably going to need something that's going to have to land on Mars. So one idea, so Paul already mentioned, is that maybe you could have like a giant drill sort of doing a stick test. Do we have water here? Do we have water here? Another idea is that you can have, instead of radar, you can actually have ground penetrating electromagnetism that looks for water as well. So those are some of the concepts thinking about how to look for underground water so far, but our orbiters look mostly for ice deposits.
Thank you. And Paul, I cut you off earlier. I want to let you finish that. And then there's another Venus question as well about Venus mission studying atmosphere or soil.
You bet. Let me just build on what just Eva answered. There's actually two spacecraft with subsurface radars right now. There's one called Mars Express, which has an instrument called Marsus. And like Eva said, both of them, that one and Sharad on Mars Reconnaissance Orbiter, designed to look for subsurface structure, mainly ice. But they've also been able to peer through the top few meters of lava in certain parts of the planet too. We've seen older lava flows under the stuff we can see on the surface, which is really cool. And we've also seen layers of ice deposits inside the poles. There's water and carbon dioxide ice that make up ice caps in Mars's North and South Pole. And we can see the history of deposition of ice over different seasons in Mars's history preserved there through these things, which is really, really cool. I could talk about this for hours, I won't. There is one of the recently selected missions to Venus, Envision, will also carry a subsurface radar sounder. It will not be looking for ice. It's hard to imagine there's going to be water ice anywhere on Venus right now, but there may be other things that we don't see on the surface that we would be able to see in the subsurface. And so Venus Express is going to be able to peer into the surface as well, which is pretty cool. What I was going to say earlier was just to say that, and to Sharissa's comment about how, if you were to heat up Earth, that our atmosphere would, basically be much thicker than Venus's. The sun is getting brighter and hotter, which is a thing suns do. And we have every reason to expect that, yes, sure, in about 5 billion years, maybe the sun will swallow Earth, although that's not entirely certain. But long before that, it will have boiled off the oceans, which is a very kind of, happy, fun thing to think about, I suppose. And in doing so, it may actually turn Earth into Venus. So when we look at Venus today, we may be seeing a glimpse of future Earth. Now, far enough that none of us here have to worry about it. But it's a good example of understanding that planetary conditions don't stay the way they are now. They tend to change through time. And we've heard about how Mars may have had water in its past and it doesn't now. Earth has water in its present, it won't in the future. So that's one of the reasons why studying these worlds is so important.
Thank you. And we have a very interesting question here from Jim. I'm going to see who has thoughts and opinions and information on it. Based on the current instruments on the missions exploring Mars, what evidence for past or current life do you think it might be possible to detect? Who wants to jump on that one?
Sure, I think I can take a first stab maybe. So this is actually one of the goals of the Perseverance rover. So from the different missions that we've had, we've sort of narrowed down that if there's gonna be life on Mars, it'll probably be microbial life. And one of the ways to detect microbial life on Earth is to actually look at different types of textures that microbes create in rocks. So Perseverance has a really, it has like 23 cameras or something. It has a lot of cameras that are designed to look for those kinds of textures. So that's one thing that would be a sure telltale sign of microbes that we're looking for. The other aspect of it, of course, is we have these instruments like the Sherlock instrument that I work on that looks for organic compounds. And while that can't tell us whether there is life or not in those rocks, if there's microbes preserved, for example, it does tell us that this rock might be really important. And that's actually some of the reasons that we have sampled these rocks. We've drilled these tubes and we collected these rocks, and they're waiting on Mars for another spacecraft to come and collect them and send them back to our laboratories here on Earth, such that we can actually study them with our really good high resolution instruments that we have in the laboratory here on Earth. So those are the two ways that we're addressing that question right now with the Perseverance rover.
Awesome. Thank you. So there was an earlier comment from Jim about, and Charissa, I'm going to see what you think about this in terms of career in science, since you're getting started on your career in science now. He pointed out that he thinks that being curious and basing theories being developed on data and evidence is important. What role do you think curiosity plays in your own pursuit of planetary science?
I definitely think that curiosity helps us form hypotheses based on what we see from both the images and the chemistry that you can get from it. And I feel like a lot of the science that comes from it is just purely inferring something based off of data that we receive. And we are trying to, it's basically the question of what do we do with this data? And it spurs the thought process of like, all right, this is when we need to collaborate, or this is when we need to get more data, or just have these talks with people and sit down and figure out what methods can I form from this to understand this better, and just help to make this hypothesis an actual theory or proven fact.
Does anyone have anything to add in terms of curiosity, in terms of your choice and your passion for planetary science, or anything else, any other factors that kind of steered you into planetary science?
Couldn't unmute myself. So just curiosity in general then. So that's, again, that's the fun part then, is being a planetary scientist. It can be frustrating sometimes that, like, why haven't we figured this out yet? Why haven't we had the technology yet? Why don't we have the data for this? So like outer solar system planets, the only data that we have for most of this is Voyager 2 from 1970s and 1980s, and that's about it. But it's not stopping us from being curious about those images and that data, that we're still forming ideas, we're still forming hypotheses of like, wait a moment, let's look at these images again. We're still looking at those images. Thankfully, we have Juno for Jupiter, and now that Juno is starting to bring back a lot of more images about Ganymede and then eventually Europa, so that's exciting. New Horizons gave us a lot of fantastic data as well. We obviously need more missions out to the outer solar system, but we still have all the data from Cassini as well. Soon enough, Dragonfly. But having that curiosity with current data, with very much old data, and then the curiosity of how can we get more? How can we get more missions? How can we get more instruments? What do we need to do to get there? So that's definitely my curiosity peak of like, what can we do, and how are we going to do it, and what kind of science are we going to get out of it?
And while you're talking about that, Caitlin, so there was a question from Daniel on YouTube asking about the Jupiter JUICE mission, the Europa Clipper, Dragonfly. These are all coming up. And what do we expect from those missions? Do you want to take a stab at that? We're down to just a few minutes left. We got a couple more questions too.
Yeah, so brief answer here is that it definitely is going to open up a lot more doors to understanding giant planet systems. How did the satellite systems form around those giant planet systems, and hopefully almost like a dress rehearsal of not only understanding planetary evolution, but maybe get us ready for an eventual mission to Uranus and Neptune. So just, we're still always testing our current instruments. There's always technology to be improved with these planetary missions. So if anything, if you take it into that way, everything's a dress rehearsal. Everything can be improved. So Dragonfly, we're sending a very, very complicated quadcopter on the surface of Titan, Saturn's largest moon. How exciting is that? But we've never done that technology before. So once that's completed and the design is in engineering and we get it there safely to Saturn, we're going to build upon that. It's not going to be a one and done thing. So it's all that technology is just getting us ready for even more future missions, but better to test it now.
Thank you so much. So there's a question here for Paul about your thoughts on the Soviet Vega 1 mission, first balloon station deployed to another planet, and your thoughts on the Venera 4 spacecraft.
Yeah, so I'll just make this quick. One of the interesting things about Venus is that the only other place in the solar system where its room temperature and pressure is about 55 kilometers above the Venus surface. In the middle of the cloud deck, it's room temperature and pressure. You could go out there, you would need a mask, but you can actually survive there for a long time. So whereas you can survive for a long time on the surface of Mars with rovers, which we've done, you could potentially float there with a balloon. And that's exactly what the Russians did. The Soviet Union in the 1980s and 85 had two missions, Vega 1 and 2, and those balloons operated for 44 hours, but they didn't carry cameras and they had the most rudimentary sensors. There is now, with modern technology, and to Caitlin's point about developing technologies, there was some amazing stuff we could do if we had a balloon in the Venus clouds. But, you know, to move back to a question a moment ago about what drives us, to me, I just want to see the pictures of other places. More than anything else, whatever the science and the history, whatever, the single thing that underlies all of my interests is just honestly photos of other places. And I would love to see a photo of the Venus clouds. That'd be cool.
Very cool. Because we are getting close to time, and because at least one of our participants here is going to be in the poster session that has already begun, I'm going to launch our evaluation poll. But while people are starting to fill this out, I would like to share a question here for anybody who has some thoughts. There's a question from Jazzy in the Philippines where Jazzy says there are very few resources in studying planetary science. And anyone have advice on how to start gathering resources for someone who wants to start studying planetary science? I know some websites for the general public, but does anyone have anything else that we might want to share?
Sure, I can maybe help out a little bit. My situation was actually somewhat similar because I'm actually from Denmark. I grew up in Denmark where we don't have a space program. And we don't really learn about space in school either. And so a lot of it for most of my life was self-study, getting my hands on any books, sort of letting that passion and curiosity drive me. And even as I was taking high school and college classes, trying to put those things I was learning in those classes into context of the books I was reading, the movies I was watching, and the YouTube. Now we have all these YouTube resources, all these online resources for learning about planetary sciences as well, which is amazing. But the really big thing I did once I was a college student was to search out programs, study abroad programs or exchange programs that allows students from different countries to actually exchange by going to a different university in a different country where they might have a space program. There's a lot of countries out there now that actually have space programs now. And so that was really the thing that that got me into doing space science as a student and further on. And you can also always reach out to people. People are very happy to always talk with others from other countries that are interested in space science, even if they're not from the same country as you. So always feel free to email me or others about the things you're interested in.
Thank you so much. So we're just past time. I'm going to let everybody have one closing statement. And Sharissa, I'm going to start with you since I know you have to get going. Everyone else should too. But any closing statements, anything else that you want to share about the conference, about the research, about planetary science, anything that you'd like to share?
Well, there's one thing that's been circling my mind, and it's brain terrain, and I just want to say that because it's just fun and it rhymes, and it's just there are just so many features and names and everything, and to build off of this comment of finding resources is just start learning the jargon, because there is a lot of jargon in planetary science, and it is definitely a learning curve, and it helps to just start early of just yes, I know what this acronym means for this rover, and then just having that under your belt already is you're just on your way of being an excellent planetary scientist.
Thank you so much. And let's go ahead and go to Caitlin next.
My little thing here is that we love to communicate, we love to talk our science. And so if you are an educator out there, if you're a museum educator out there, if you belong to an astronomy club, it's okay to ask a local planetary scientist at your local university, or even virtual, now that we're completely virtual now, to we're totally okay and enthusiastic to share our science with your groups, and just email us and say, we would love to have you talk about your science to our astronomy club, to our classroom. We have the Solar System Ambassadors, which is an amazing program. So use that network system, because we're happy to talk about our science to a myriad of groups.
Thank you. Thank you. Paul, would you like to go next?
Sure, I'll say just two things. If you want to get into planetary, and we've heard this already, it's extraordinarily diverse. You could be a biologist or a geographer. You could be a physicist or even an engineer. Whatever your discipline, there will be a home for you in planetary science. It's not one discipline, it's a whole confluence of things. And to the question we had at the beginning about for little ones, specifically in terms of doing this, getting online, joining astronomy clubs, getting stuff in your local library. But when it comes to schooling, take as much STEM stuff as you can, math, physics, chemistry, biology, as much of that as you can. You don't have to be brilliant at it. You don't have to be a genius. You do have to work hard, which is true for a lot of things. But really, there's going to be a place for you. And the second thing I want to say is, we have never had this many missions in flight or in development. This is the arguably best time to be a planetary scientist. It's only going to get better. We have more missions in the pipeline. This is a time to join us if you haven't already, or if you want to get into it, whether you are a scientist or you want to learn, be a communicator, or you're a teacher, or just an interested amateur. who wants to learn more about this stuff, there's a space for everybody, say through the Solar System Ambassador Program. But this is one of the most exciting times in human history for understanding our place in the universe. So grab every opportunity you can.
Thank you so much. Eva, you get the final word.
Sure. Let me just echo what all of my fellow panelists have said already. It indeed is a really exciting time to be doing space science. I also think it's one of the most inclusive periods in doing space science, and there truly is room for everyone. So we've talked a lot about curiosity, we've talked a lot about passion, and also never give up. You know, always follow your curiosity and passion, and there will be a place for you.
Thank you, all of our speakers for tonight. Thank you, Grace, for helping with all of this and helping to coordinate it all. And thank you for all of you for joining us tonight. We really appreciate you. Let us know if you have questions or feedback. There is a form that you can fill out to give us additional information. And have a great evening and a great LPSC. What's left of it for this week, everyone.